All right, this is the last little section of 2-3. This is like the fourth section. I broke it down into fourths. So this is the last part of this, and let's talk about it. It shouldn't take too long. We're going to talk about parallel lines and perpendicular lines. So let's first do this. Let's put a definition down for parallel. Probably know that already, but we're just going to write it down. So here's a definition of parallel lines. So write this down. It's basically, I think I kind of shorthanded a little bit from what the book says, but it's basically this. It says when two lines do not intersect. All right, so the two lines basically are not going to touch each other, okay? So they'll never touch, they'll never curve over and hit each other, they'll never intersect each other. That is what we're going to talk about at first, okay? Parallel lines. You probably knew that already, it's nothing new. So we're just going to give a little example, a little graph right here. And let's put some lines in here. Let's change colors. All right, and I'll tell you what. Yeah, let's do this. Let's put a dot right there. Put a dot right there. Not a dot, a point, I should say, if I'm going to be mathematically correct. Connect these. They don't have to be in that exact position. I'm just doing that for this example. So we'll make this graph go about like that. It's a line, so what do I need to put on the ends of these? Put little arrows, okay? So there's one line. So if I want a line that is parallel to this line, watch what I'm going to do. I'm going to copy and I'm going to paste. And I'm just going to put it somewhere. Let's just put it right there. Should be good enough. So if I copied and pasted it, it's the same exact line, except I just moved it up or down. Everybody with me on that? So I just moved it up or down on the y-axis. So they would be two lines that are parallel. A lot of times we'll put M1 and M2. Okay, we'll call this. Now, the reason I put M, what does the M stand for that we've been talking about recently? The slope, okay? And there's a reason I put that. So the slope of line 1, that's what the 1 is for, and the slope of line 2, just eyeballing it, what do you think? And I copied and pasted it, so maybe that might help you a little bit too. So what do you think might be true about the two slopes? They're exactly the same, okay? And that's really the key to what this lesson is. Well, half the lesson is, the parallel part of the lesson. Bill, you want to hit that first light right there? I don't know if it helps you see the screen better or not. And then put the second one up. Yeah, there you go. That's a little better, I guess. All right, so the two slopes are exactly the same. If you wanted to, the reason I put those points there, if you wanted to, let's see if they really are the same. Let's do some counting. How would we know, just instead of just by eyeballing, if it's on a graph and you got some points on here, how would you know, how would you be able to check to see if these two slopes are the same? What do you think? Take 2 points on the line and check what? Check the what? The slope. The what over what? The rise over the run. So what is this rise right here? From here to here, we did what? We went 2. Yeah, we went down, though. We started up here and we went down, so it's really what? It's really -2. And then we ran, okay? We're here, so we go to the left. So let's count how many? 1, 2, 3, 4, what? 5? So the slope of this line is -2 over -5. Get rid of that thing. All right, so it's rise over run, -2 over -5, which is just +2/5. Would you agree? All right. Let's take 2 points that we know. Now, look, I would not pick like a point like this because I don't know exactly where that is. Do you see that? Okay, so I want to pick a point that looks like it lies right on the line or right on an axis. So let's put that point right there. And let's see, where else does it look like it crosses? Looks like it crosses right there, doesn't it? It may be off a little bit. I'll do this. 1, 2. Okay, let's pick this point right here. And I did that on purpose. Say that again. What's your question? Okay. Yeah, it's got to be on. See, that looks like it could be intersecting that little spot right there, but it's really off just a little bit. Okay, I think it hits right there. So again, what can we do? We can check the rise over the run. So that's -2. That's -5. Same exact rise or run. So the slope of M2 is also 2/5. So the whole point of this is, how do we know if two lines are parallel to each other? What do we check? What do we look for? We look for the slopes, and we look to see if the slopes are what? The same, okay, or equal to each other, all right? If the slopes are equal to each other, then the two lines are parallel. So I don't even have to see the graph. If I just have the equation, all right? So let's just make one up. I didn't do this in my notes, but we're just winging it here. What if I had y equals -2? I don't know why. Let's not use -2 because I used that before. Let's use 3/4, okay? X, I don't know, -2. So I give you a graph like this, and then I give you another graph. It's y equals 3/4 x plus 5. What can I tell you about these two lines right here? I can say they're parallel, right? What do I check? I check the slopes. They both have the same exact slopes. Now, they have different intercepts, but so did these two, didn't they? This had an intercept at what? +2. This had a y-intercept at what? -3. Okay. So if I wanted to find out the equation of this first line right here, this line 1, what would it be? It would be y equals what? What's the slope of that first line? 2/5 x what? What's my y-intercept? +2. Right. So that's the equation to that graph. What would the equation to this graph be? Y equals, well, we already figured out the slope, 2/5 x, and then what? -3. So that would be the equation to that slope, or to that line, I should say, not slope. Does that make any sense? All right. For some reason, when we introduce graphs, it throws people off a lot. And a lot of people say, oh, I hate graphing, and I hate y equals mx plus b, and all that kind of stuff. A lot of students do. Not everybody, but a lot of students do. But if you take it little piece by piece, it should make kind of sense to you. All right. Now, they give you this theorem. I'm not going to write it down. It's too long to write down, but it's in the book. And it basically says that if two non-vertical lines are parallel, now it says non-vertical, okay? Why do they say non-vertical? What about two lines that are actually vertical? What's true about the slopes of two lines that are vertical? Think about it. Think about the story. I gave you this big old long story about skiing down a slope that looks like this. I gave you the rappelling story. Do you remember the rappelling story? Yeah, okay. So what's going to be left of me down the bottom if I fall? I'm going to be nothing. I'm going to be undefined, right? I won't exist, all right, if I fall. It's kind of morbid, but that was my example. So these are not zero slope. What are they? They're undefined slope. And you know what? I was thinking about this the other day. I don't know why, but I was. I said, when I taught this lesson, undefined slope. I don't think I said this, but you could also say that it has no slope. That's different than zero slope. You follow me on that? Okay, no slope means it doesn't exist at all. Zero exists. It's a number. It's on the number line. I can add zero. I can multiply zero. I can do all kinds of stuff with zero. Okay, so zero exists. No slope means it does not exist. Everybody got it? So the reason they say non-vertical lines is because these don't have a slope anyway. And you can say, well, they both don't exist. Yeah, but they don't really have a slope at all. They have what? No slope. Make sense? All right. So that's why it says two non-vertical lines. I'm sure that wouldn't bother you when you looked at the little theorem right there, but I thought I'd throw that out there for you. So it says two non-vertical lines are parallel if and only if their slopes are equal and they have different y-intercepts. Now, why did they say they have different y-intercepts? Because, copy, and let's do this. Let's paste in place, okay? So watch. What if that first line had the same y-intercept as that line? Then they wouldn't be two separate lines, would they? They'd be the same exact line. Does that make sense? Okay, so that's why I just want to make sure you understand this theorem. Okay, it says two non-vertical lines. That's why they say non-vertical, because we're talking about their slopes, and a vertical line doesn't have a slope. So we can't talk about the slopes on vertical lines. That's why they say non-vertical lines, okay? And it says they're parallel if and only if their slopes are equal. If and only if basically means you can switch the if and the then part around. It says if two non-vertical lines are parallel, then their slopes are equal. Or you could say if the slopes are equal of two lines, then they are what? Parallel. Okay, that's what if and only if means. I can see I put you guys to sleep already on that one part, but I just feel my obligation as a math teacher to explain the whole entire theorem to you, even though you don't give a rip about it. I can tell. All right. So let's do an example. All right. Example 10. Example 10. So it says show that the following lines are parallel. All right. Show that the following lines are parallel. Do you know the symbol for parallel? It's just two up and down lines like this. You've seen that before, right? Okay, we're going to have one for perpendicular. You probably know what that looks like already. But I'm just going to say show that these two lines are parallel. Okay, so here's the first line, L1, they call it. And equals 6. And then here's another line, L2. And it's 4x plus 6y equals 0. Can I just look at these two lines and tell if they're parallel right off the bat? I don't know. Maybe you're a genius and you can. I can't. I'm definitely not a genius. So I can't look at these and just say, oh, yeah, they're parallel, or no, they're not parallel. What do we have to do to figure out if they're parallel? What did we just go over? We have to show that the what? That the slopes are the same. They're equal to each other, okay? Can I just look at this right off the top of my head and figure out what the slope is? Probably not off the top of my head. I'm going to have to do a little figuring, right? I have to do a little bit of algebra to figure out what the slope is. So let's actually do the algebra. So how would I find the slope of a line that looks like this? Well, I'd solve for what? Solve for y. Solve for y, okay? Y equals mx plus b. That's what I want it to look like. Then once I get y equals mx plus b, then I can just look at it and tell what the slope is. Does that make sense? Right now, I just can't look at this. Again, people smarter than I am can probably just look at this and tell what the slope is, right? And there's a ton of people smarter than I am that could probably do this, but I can't. So what I'm going to do is I'm going to actually solve for y. So I'm going to get rid of the 2x. So move the 2x over here. How do I do that? I subtract a 2x. That 6 is already over there, so I put a plus 6. This is basic Algebra 1 skills. Okay, divide by 3. Divide everything by 3. Everybody's familiar with doing this, right? Negative 2/3 x plus what? 2. Do I even care what the y-intercept is in this problem? No, all I care about is what? The slope. Okay, so the slope of this one is negative 2/3. So let's come over here and do this one. We're going to do the same exact thing. We're going to check the slopes. Bryce, you with me? Did you get enough sleep last night? Doesn't look like it. Well, don't catch up on it in here, okay? So let's do the same thing. So 6y equals negative 4x. Divide by 6. Divide by 6. Reduce 4 6. That's 2/3 negative x. It's plus 0. Again, it doesn't matter what our y-intercept is for this particular problem. We don't care. All we're looking at is the slope. So what's the slope of this one? It's negative 2/3. What's the slope of this one? It's the same exact thing, negative 2/3. So what did we just do? We just showed that the lines are parallel, okay, by showing that the slopes are equal. If you want to, you could do this. You could say like M1 is equal to negative 2/3 and M2 is equal to negative 2/3. That kind of shows that the slopes are equal. That means that they're parallel. Pretty easy, right? Yeah. They're just warming you up for this problem right here. This is kind of more of the problem that you might see on a quiz or a test or something, okay? So this one says, again, it's a lot of writing. I'm not going to sit here and take the time to write all this stuff out, but it's in the book. It's example 11, so you can look to see what the exact problem says. It says, find an equation for a line that contains the point 2, -3. I will write that down. So it says, find the equation of a line. So what are we looking for? Are we just showing that the lines are parallel? No. We're looking for an equation of a line. So what's our answer going to look like? It's going to look like what? An equation of a line. Y equals mx plus b. Everybody with me? All right. I somehow doubt that, but we're going to keep going. So 2, -3. And we want to show that the line goes through this point, it contains this point, and is parallel to It's parallel to the line 2x plus y equals 6. It's very important that you understand what we're trying to do, right? Don't just memorize it and memorize the steps. Understand what we're trying to do. We're trying to find the equation of a line that goes through this point right here, 2, -3, and is parallel to this line right here. That's the key. It's parallel to this line. It's not going to be exactly this line, but it's parallel to it. So what do I have to find about this line right here? If they're parallel, we're going to get two lines. We're going to get another line that's parallel to this one. So what must be true about the two lines? They must have the what? The same slope. Okay, so what do you think we're going to have to do to this? Find the what? Find the slope. This one's really easy. I could probably do this one in my head, but we'll write it out. Okay, so I subtracted 2x from both sides. So y equals -2x plus 6. So what is the slope of this particular line that they give us? It's -2. So the slope is -2. It's not what they're asking, though, is it? It says find what? An equation of a line. That's not enough. I got to go y equals mx plus b, don't I? There's a couple ways you could do this. The way the book does it, I'll show you how the book does it after I show you how I'm going to do it, okay? So it's a little bit different, but it's kind of the same. You'll get the same answer. So this is what we want. Well, I got a y, I got an x, I got a b, and I got an m. I got to fill in here. Actually, I know 3 of those 4 things. Excuse me. I know 3 of these 4 things. I definitely know the m, right? I know the slope. So I know the slope is what? -2. Do I know the b? Do I know? No, I know the b for this one. I know the y-intercept for this line. But my line I'm trying to figure out, it's going to have a different y-intercept than this line does. So it's not going to be 6. All right? But I do know a point that it goes through. So what is this point? This is an x and a what? And a y. So guess what I'm going to put in for x and y right here? 2 and -3. Everybody see that? Okay, so that's what I'm going to do. I'm using this little equation. I'm going to put all the stuff that I know into this. So what is the y? What am I going to put right here then? -3, because that's my y. And then the m is being multiplied by the x. What's the x? It's 2. Do I know the b? Do I know the y-intercept? Nope, that's what I'm going to find. Okay, because I know what my slope's going to be. Now all I got to do is find the y-intercept. And now I just do a little bit of math and find what b is. This is easy. -3 equals, what's that? -4 plus b. How do I get b by itself? Add a 4, add a 4. So what's b equal to? +1. So I got the 2 things that I need. I got the slope, I got the y-intercept. Let's put it all together, make it look real nice, like an equation of a line. Y equals m, which is -2x, and then the b is +1. So that is the equation of a line. So look, this line right here and this line right here, I'm not going to circle it because it's not my answer. Okay, these 2 lines right here have the same slope, but they have different intercepts, don't they? Actually, I should have boxed this one in. Okay, they have the same slope, which is -2, but they have different intercepts. This crosses the y-axis at +1. This crosses at +6. All right, and this is your answer. But to tell you the truth, if you look in the back of the book, because I'm just going by what the example does, for some reason, I don't know why, it seems like in high school math books, they want you to write at y equals mx plus b. But it seems like in this book, they're writing the answer in the general form. Do you remember what the general form is? ax plus by equals c. Remember that? So let's go ahead and do that, because now I would be fine with this. If you wrote it like that on a quiz or a test, I'd be perfectly okay with that. All right, so you could stop right there. But what I'm going to show you next is in the book, if you flip to the back of the book, they're going to write it in general form. So you need to be able to take a look at your answer and see if it's the same thing that the back of the book has. Does that make sense? All right, so let's do that. Let's change this into this. Well, I want the x's first, right? So let's do this. Let's move this over to the left-hand side. So how would I do that? I'll tell you what. Let's write it out again. Really only one step we have to do. We're just going to add a 2x to both sides, right? Add a 2x. And we'll keep this 1 over there because you got a c there, so we'll just keep that over there. So how would we write this? We'd write it 2x, what? plus y equals 1. So this is how you're probably going to see the answer in the back of the book when they ask you to do this. Because that's how they write the answer in the example. So I would assume, I haven't looked in the back of the book, but I would assume that this. So would I give you credit for that? Yep. Would I give you credit for that? Sure.
It wouldn't be 2x minus 2x plus 1 because y equals negative 2x plus 1.
No, I just added a 2x to both sides. I wouldn't have x on both sides.
No, I'm saying
you gave me
already one equation. So like, because you have 2x plus y equals 1, but y equals negative 2x plus 1.
but all I did, you're making it more confusing than it really is. All I did was change the form of it. Okay, this and this are exactly the same thing. Okay, except I just put the x and y on the same side. That's all I did. Okay, so all I did was take this and whoop, move it over here. That's all I did. Okay, it's the same exact thing. It does give you both? Okay, all right, good. So, I mean, because this is just an added step, right here. So I wouldn't even worry. If I were you, I wouldn't worry about it. So if they give you this answer in the back, that's good. Just keep it. Just keep it y equals mx plus b. We good? Do you know how I put it into this form right here? If you look at the example in the book, they use the point slope form. Do you remember what the point slope form was? Y minus y1 equals m times x minus x1. Well, how in the world could you get the same answer? Well, if you remember how we got this formula right here, this equation right here, we got it from this. All right, so really it's the same thing. But so let's just do it just for fun, okay? Y minus y1. What was my y? It was negative 3, right? Equals the slope. Our slope was negative 2. X minus x1. What was our x1? It was 2, wasn't it? Okay, so watch this. Let's see if we get the same thing as we did before. What's that? Y plus 3 equals, let's distribute that, negative 2x plus 4. Let's get y by itself. So we subtract a 3 from both sides. So we get this. Subtract a 3 from that. We get a 1. Look at that. That is the same thing. Whoops, I don't have enough room here, but you got your notes. So that and that are exactly the same thing. So it doesn't matter which way you do it. I kind of prefer just putting it into y equals mx plus b, because that's the way you're going to have to write it anyway, right? Because it's an equation of a line. So I would just use y equals mx plus b, put the x in for the x, right? The point that they give you right here. Put that x in for that x. Put this y in for that y. You already figured out what the m was. You solve for b, and then you're good to go. All right, I know that was a little lengthy, but you can always go back and look at it on YouTube. All right, let's do one more. Let's do perpendicular lines. All right, so let's write that word down. Perpendicular. Do you remember the little symbol for perpendicular lines? So one goes straight up and down, but the other one does what? Across the bottom like this. Why do they make it like that? Why is that the symbol for perpendicular lines? Because these two lines make it what kind of an angle? 90-degree angle or right angle, okay? So that's why that is. So instead of writing the word perpendicular, which is pretty long, sometimes I'll just put that little symbol for perpendicular. All right? Let's do, oops, I didn't copy it. Oh, I got to run back up here. Sorry. Yeah, let's just use this thing. There we go. Let's grab that. Let's go back down to here. There we go. Didn't take too long. So let's put a couple lines. I'm going to try to let's do this in a different color. I'm going to put one right here and one right here. And I'm going to connect those two lines, or those 2 points, I should say, right there. Stretch this one out a little bit. It's pretty close. All right, put some arrows on there. Now what I want to do is I want to make a line that's perpendicular to this line. I should have practiced this before. Let's copy and paste it. And I think there's a way to move it around. What did I do before? Did I go up here? Nope, didn't do that. Where did I go? oh, transform. Transform, and let's put a degree. Let's change that to, let's stick a 90 in there. Put a 9 in there. Let's see if that works. Ah, yeah, it worked. Look at that. I'm a genius. Oops, not so much. But yeah, there we go. Let's put it right there just to make it kind of a little bit easier for us. Now I know by what I just did right there, I made it 90 degrees, so I made it perpendicular. But I want you to look at the slopes. Let's take a look at the slope of line 1. And then this is the slope of line 2. Let's put some arrows on here, make them look like lines. There we go. Let's take a look at the slopes. So what is the slope of line 1? Well, it goes from here to here. So let's count. 1, 2, 3. So it's a rise of -3. And the run is 1, 2, 3, 4, 5. It's negative. So it's basically just 3/5. Now what I want you to see is this. Let's look at the slope of line 2. So let's take a point where it looks like it goes right through. It looks like it goes right through here, doesn't it? And where else does it look like it goes right through? Maybe, yeah, I don't want to go halves though, because that's too hard to estimate. Because I don't know if it's a half. I don't know if it's like a third. You know, it's hard to estimate. So that looks like it goes right. It's good there, okay? So now let's do this. Let's go from this point to this point. Let's rise over run on this. You could go up and to the left, or you could go down and to the right. It doesn't make any difference. Let's go down and to the right. So let's go down to here, and let's go over to there. Let's see what we get. How far do we go down? 1, 2, 3, 4, 5. So the slope of line 2, it's down 5, and it's what? 1, 2, 3, to the right 3. Now look at the two slopes. Are the two slopes the same? No, they're obviously not the same. But look, there's definitely a relationship between those two. What looks like, okay, the reciprocals, right? But not just a reciprocal, there's something else. They're negative reciprocals, that's right. This is positive 3/5. This is what? Negative 5/3. That's going to be true with every two lines that are perpendicular to each other. You see that? So they're going to be negative reciprocals. And I'm glad you said negative reciprocal, because that's the phrase that I use. Some teachers use different phrases, but I use the phrase negative reciprocal. Did I spell that right? I think so. Okay, you know what a reciprocal is. We talked about that earlier in the year. You just flip the fraction, and then you just take the opposite sign. When I say negative, it means you take the opposite sign. So for instance, what if I give you a line that has a slope of 4? What is the slope of a line? I'll put a little perpendicular sign there. Okay, that means what is the slope of a line that's perpendicular to this? So I could write it like that, couldn't I? So what is the slope of a line that's perpendicular to a line that has a slope of 4? What do you think? It's negative, right? This is positive, so you change the sign and you flip it. So you flip 4 and it's 1/4. These two lines right there, those two slopes, they're perpendicular to each other. Make sense? So I could take, if I know what the slope of one line is, I could always find the slope of another line because it's the negative reciprocal. Or in the book, I'm not going to write this out for you, but if you look in the book, they say that the two slopes, M1 and M2, they multiply, put a little dot right there, they multiply to be -1. Let's see if that's true. Do you remember what the first two slopes were? 3/5 and -5/3. So 3/5 times -5/3. What does that equal if I multiply those together? That cancels out to be a 1, right? That cancels out to be a 1. So what do I get? I get a -1. So that works, doesn't it? What about that 4 -1/4? Does that work as well? 4 times -1/4? Yeah, absolutely. I get a -1. Every time, if I take the slopes of two lines that are perpendicular to each other, their slopes will multiply. The product of their slopes will be -1. Okay? That's the way they talk about it in the book. All right? I kind of like to think about them, I kind of like to think of them as being negative reciprocals. All right? Either way, it works. Let's go to an example. I've talked long enough. Let's get this over with. This is easy. Example 12 just is kind of a warm-up. I probably won't ask you this. It's too easy for a quiz or a test, but it says if a line has a slope of 3/2, what is the slope of a line that's perpendicular to one that's 3/2? So I got a line, I count it, 3/2, and I want a perpendicular line. What's the slope of a line that's perpendicular to this one? -2/3. Couldn't be easier, right? Pretty easy. Make sense? If you multiply them together, what do they multiply to be? -1, okay? I'm not going to worry about that, but let's do a problem that you might see on a quiz or a test. You'll definitely see a problem like this on a quiz or a test, not might. So it says, find the equation of a line. So as soon as you see that phrase, finding the equation of a line, I'm thinking this. Okay, this is what my answer is going to look like. You with me? I just got to figure out what the slope and the y-intercept is. So this is what I want to try to figure out. And it says it goes through the point 1, -2. Now this looks very similar to the one we just did with the parallel. But it's different because it's not parallel. It's what? Perpendicular. So really the only thing different between the parallel and the perpendicular is we don't just use the same slope. We use the negative reciprocal of the first slope. You got it? All right. So it's perpendicular, not parallel. It's perpendicular to this line right here. X plus 3y equals 6. And on this one, they actually, I don't think they did on the other one. They actually ask you to graph it as well. So make sure that you look for that. All right, I got 5 minutes. I can do this in 5 minutes. First of all, we got to find the slope of this. Excuse me, find the slope of this line right here. So what do? Let's get the y by itself. So I subtract an x, divide by 3. All I care about is the slope, but we'll do the whole thing. So what's this? -x/3. There's a 1 up here, isn't there? So isn't that the same as -1/3 x plus what? 2? So what's the slope of the line that they give me? It's -1/3. What's the slope of the line that I want? This perpendicular one. If the slope that they give you is -1/3, what's the slope of the perpendicular line going to be? It's going to be +3. So that's what I'm concerned about, okay? This is what I want to find right there. So I know a slope, and I also know an x and a y. What are my x's and y's? Or what is my x and y? It's right there and there, isn't it? With me? So now I got 3 of the 4 things, okay, to my originally formula or equation that I wanted. So let's put them in. I'm going to write y equals mx plus b again. Let's plug and chug. So I know the y, it's -2, equals the slope, I just figured that out, is 3, times the x, which is 1, and then I put plus b, and I solve for b. So that's -2 equals 3 plus b. Subtract a 3 from both sides, so b is -5. Now I'm ready to put it all together and make an equation of a line. So now I'm going to write y equals mx plus b, but I'm going to fill in what I know. Excuse me. So y equals m. What did I say the m was? 3. That's my new slope. It's not -1/3. If it was -1/3, it would be parallel. They're perpendicular. So it's y equals 3, and then I just stick an x right there. Now I went through all this to find my y-intercept, which is -5. That's my answer right there. That's the equation of a line. Both types of problems are kind of the same, right? You kind of do the same type of work, except for the perpendicular. To find the new slope, you just go negative reciprocal of the old slope, and then you'll be good to go. What else does it say to do to this? Graph it. That's pretty easy, isn't it? Why did I do that? Because I thought I copied that graph. Maybe I copied that line again. Let's copy the graph. And let's keep that right there. Let's put that right there. This is pretty easy stuff to graph. If all I do is ask you to graph a line, it's already in y equals mx plus b form. So we go -5. So we go 1, 2, 3, 4, 5. Why did I do that? Because that's the what? Y-intercept. Now I got to find the slope, which is 3 over 1. So I rise 3, 1, 2, 3, run 1. If I wanted to do it a few times, 1, 2, 3 over 1, do you see that? Doesn't matter. how many up 3s and over 1s I go, they're still going to line up. So let's connect them. Oops, that's a circle. I don't want a circle. There we go. And then like that. Always extend it. Don't just start and stop at the points. Okay, I said that a couple times before, and I think on the quiz, somebody just started and stopped right there. Okay, extend them, put arrows on them. I didn't mark it wrong, but extend them, put arrows. That looks like a line. So that's your answer. It's a dual answer. Okay, you got to get the equation and you got to graph it. We good? Yeah. It's not so bad, is it? Remember doing this back in whatever class you did this in? Here's your homework. No moaning and groaning because I gave you a free weekend. No homework. This is, I think it's part 3. It's page 186. And it's 59 to 70 all. There it is. All right. Make sure you do them, okay? Make sure you understand what's going on. Christian, put it down. Put it down. Put it down. Or I take it. Put it away. Don't say anything. Put it away, or I take it. Okay. You got pencil, you got paper, write it down. All right, enough of that.